Good afternoon. Today I am going to explain about coordination compound. Coordination compound. Next, Werner's theory. In Werner's theory, all coordination compounds, metals will show two valencies. One is primary valency. This primary valency is ionizable. That means metal is attached with negatively charged ions. That means metal will be valence satisfied by negative ions only. It will give also oxidation number of metal. Okay, and secondary valency. It is a non-ionizable. It will be this valence is satisfied by negative ions or neutral molecules. Coordination. It will give also coordination number of central metal atom. It will be if any ligand directly attached to this central metal atom, it will be secondary valency. So in this cobalt NH3 NH3 is attached directly to the central metal atom. This outside 3 chlorine atoms, it is attached with very weakly with dotted line. This primary valency represented with the dotted line, secondary valency represented with normal line. Okay. Next, difference between double salt and complex. Double salt means a salt which is produced by 2 or more simple substances to form double salt. Double salt, if you dissolve in water, it will ionize into simple ions on dissociation. For example, potassium ferrocyanide, ferrous ammonium sulfate, and potash alum. These are all the things. It will dissociate into 4K plus Fe2 plus CSI. Sorry, simple salt is, so this is a double salt is FeSO4. Double salt FeSO4 NH4 twice SO4. Here Fe plus 2 sulfate ion, ammonium ion, sulfate ion, all ions will be completely ionized. But complex not ionized into simple ions. For example, potassium permanganate, potassium ferrocyanide. If you take ferrocyanide, this ions only will be given into simple ions. This is a complex anion. Further, it will not give any Fe2 plus and cyanide ions. Next, what is meant by coordination entity? If a central metal atom or metal ion, if it is bonded with a fixed number of ions or molecules, if it is metal attached with a ligand, if it is enclosed in square bracket, then it is called coordination entity. What is meant by central atom or central ion, metal ion? Any metal or metal ion which is present in the center of the complex. Next, ligand. Ligand means an ion or molecule which is bonded to the central metal atom in a complex is called a ligand. Ligands will be classified into ambidendant ligands, unidentate ligands, didentate ligands. Ligand, if it is having single donor atom, then it is called unidentate ligands. For example, water, O is connected to the central metal atom. Ammonia, N is connected to the central metal. This is a pyridine, carbonyl group, nitrosyl group, triphenylphosphine, halides, and hydroxyl groups, cyanide group, nitro group, and nitrito group, oxide group, thiocyanide group, acetate group. These all are unidentate ligands. If the ligand is having 2 donor atoms, then it is called didentate ligands. See, this is a ethane 1,2 diamine, CH2, NH2, NH2. This nitrogen also will contribute electron. This nitrogen also will contribute electron pair. Next, oxalate ion. It is a COOH, oxalic acid, COOH. In that if H plus is removed, COO minus COO. Ambidentate ligands. if the ligand is having two different donor atoms, it is called ambidentate ligands. Suppose a thiocyanide, if sulfur is attached to the metal atom, that is thiocyanide. If it is in this nitrogen is attached, thioisocyanide. So it is ambidentate ligands. Coordination number, a number of ligands directly attached to the central metal atom is called coordination number. Platinum directly attached with 6 chlorines. Iron attached with 3 oxalate ions, but each oxalate is having 2 donor atoms. So coordination number is 6. Why? Because 2 donor atoms. So 2 into 3, 6 coordination number. What is meant by coordination sphere? Central atom or ion ligands attached to it, and everything is enclosed in square bracket, and it is called as coordination sphere. Next, oxidation number. Oxidation number means it is one charge of a metal when it is carried, when all ligands are removed along with electron pairs. When all ligands are having taken by one electron pair, what is the resultant charge of that metal is called oxidation number. It will be represented by Roman numerals in parenthesis. In that bracket, it will represent nomenclature of coordination compounds. Naming, first in nomenclature, cation must be named first. Next, ligand is named in alphabetical order. Ligand is named in alphabetical order. If it is anionic ligands, there are ligands are 2 types: anionic ligands and neutral ligands. If it is anionic ligands, all ligand names end with O. For example, chloride plus O, chlorido, oxalato, cyano. If the ligand is repeated one time means mono. If it is ligand is repeated 2 times, di, tri, tetra. Okay. If the some ligands, neutral ligands will be named with the same name, except water means aqua, ammonia is amine, CO is carbonyl, NO is nitrosyl. And if any ligand include numerical prefix, so in ligand itself, again any numerical number, if it is repeated, then we can 2 times repeated means bis, 3 times repeated means tris, 4 times repeated means tetrakis. And oxidation number, always oxidation number represented by Roman numerals. If the complex is cation, if it cationic complex means, then it will be metal is named as an element name only. For example, cobalt means cobalt only. If the complex is anionic complex, if the complex is anion, metal is named as a element name plus 8. Cobalt means cobalt 8 will be added. Writing formula. Here also first metal is written first. Metal should be written first. Metal name metal name is written first. Ligand is written in alphabetical order. Next, coordination entity is written in enclosed and written in enclosed square bracket. There is no space between metal and ligands when you are writing formula, writing coordination compounds complex formula. The coordination entity with the charge, that the complex charge must be represented on a right hand side superscript. Next, isomerism in coordination compounds. Isomerism is linkage isomerism. Suppose linkage AGE you can remember as ambidentate ligands. Coordination compounds contains ambidentate ligands. So here A means ambidentate ligands. So ambidentate ligands means both different donor atoms. For example, in this complex, CONH3 is common. CONH3 is common. Nitrogen is attached to the cobalt. See, now if it is nitrogen is attached to the cobalt, it is yellow in color. Okay, it is, we can call it as a nitrito N. When oxygen ONO, oxygen is attached to the cobalt, then it will be red color. So different properties. Coordination isomers, interchange of ligands between cationic and anionic complex. See, ammonia is exchanged. Ammonia is coming here, the cyanide will be going here. So exchanging of ligands between anionic and cationic complexes. ionization isomerism. Counter ion is outside ion is coming inside, or inside ion is going outside. That is the ionization isomerism. Ionization isomerism means compounds which have same molecular formula but gives different ions in solutions.